Thank you for reminding me.
You should convince Carol to do recordings. I brought it up one class like a month ago to her. But for her class, the way she zooms through examples so quickly, like 20 examples every class, I think her students would really benefit from that.
And she talks fast too.
Yeah.
I just cannot.
She uses her hand moves around real quick.
Yeah, yeah, she's a lot faster. I just cannot think that fast. I'm a slow thinker. I have to stare at my own code for like 10 minutes and go like, oh, so that's what I was doing.
We were thinking about different things though too, probably, or you guys think of teaching.
Well, she has a literature background. You know, she's an English major, so.
Is that why she's teaching business English?
That too.
That's kind of interesting. JavaScript, PHP, and business English.
Yeah, they're all languages, right?
Yeah.
They're all languages of some kind. So let's see. I'm gonna go to tools and see if there's any update to perform. But this part is really kind of important because if you don't keep all these things up to date, it can cause an issue. I mean, I know that the latest version can have its own issues too, but if you don't update, you run a bigger chance or run a higher probability of running into issues and problems. So I'm gonna do this first and get my repository up to date. And it's not gonna stop. Okay. Oh, okay. It is working. It's just working kind of slowly. All right. So everything is up to date according to this, which is good. So I know I can get it out of this one. Go back to Eclipse, and then run Eclipse. And also the browser, because I need to run the browser to teach the class. Right. And I have to change my workspace folder now because it's not at the same place anymore. I'm not starting up Eclipse at the same place that it used to, so I have to switch this to a media persistence media user persistence home user again, and then workspace here. There we go. Okay. And then from good morning. So is 12 hours enough of a break for me?
Yeah.
Cannot find SDK folder because that also has changed. So I have to move that one also. See. Okay. So I'm gonna have to move this one over to all the way to /media user persistence home user SADT something and then the SDK folder. There we go. Okay. There we go. All right. It's just.
I wonder how badly it would crash if you just unmounted the partition you're working on right now and just mounted persistence.
Probably not too bad, because you can do a bind. What a bind does is it will just kind of override your current folder to another folder. So you're basically making a sim link between the two. It will work. But I have made all these changes already, so it's a little bit too late for that. Right. Well, today we'll talk about multi-threading and processes. So it's going to be I think it's going to be an exciting discussion. Especially for people who are trying to write games, or stuff that requires something to happen in the background. In other words, you're not relying on it's not strictly just, okay, you do something to the application, it responds to what you're doing, and then you would do something else, and then it responds to what you want it to do. Okay, so this one, has the capability of having something to happen in the background to keep, something, some other things up to date. But there's a particular issue with this type of multi-threading program, and we'll talk about it today. That's basically the the quote-unquote centerpiece of today's lecture. So we are now moving on from graphics programming to threads and processes, which is actually a part of the curriculum. Okay, the way I wrote the curriculum includes all these topics also. But we kind of touched on these topics already just a little bit the other day, because I talked about how the current way of doing things with graphics is not suitable to write most games, because most games it's not just okay, here's something that I'm doing, so I click something, I swipe something to trigger a reaction from the application. But after the reaction from the application just sitting there and say, okay, what else do you want me to do? And it's just sitting there waiting for you to do something else. Most games require some other thread to be working in the background to move things around, to update the background, to move characters around and stuff like that. So that's why with the previous chapter in graphics programming, it's not going to be okay, it's not going to be suitable for writing most games. It's okay for most applications where it's just like online banking. Okay, with online banking you have to set up a timeout type of thing, but even a timeout type of thing is not necessary, because what you can do is you can record the last time or the time of the last user interaction, so the next time the user tries to do something, you can measure the time in between, and if it's more than, like, let's say 2 minutes or whatever amount of time you want to set up for a timeout, then you can just say, okay, can't do it, I'm logging you out, you have to re-authenticate to come back in. So even for that purpose, there's no real need to have something happening in the background, even though it would be nice if the application can kind of update the screen all by itself and say that, okay, you're being automatically logged out because you have not done anything for the past 2 minutes. Okay. So what we'll do today is to first introduce the basic concepts of processes and threads in the context of an operating system, and particularly in the context of Android or Linux, okay? Because Android processes and Android threads are actually modeled completely after Linux threads and Linux processes. And then the next topic, each one is kind of short, so don't worry, we're not going to cover a whole lot of stuff, but each one is kind of short. The UI thread or user interface thread is the main thread. This is the first thread that gets started when you start an application. This is also the thread that by default will get the that will handle all the different events. So the on blah 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 events, they're all handled inside, they're all executed by the UI thread. This is where the looper is. Okay, you remember the loop that we talked about on Monday? There's a call to get the next message from a queue, and then you dispatch the message. That loop is run inside the UI thread. When you have multiple threads and the other threads, the threads other than the UI thread needs to update the screen, now you have a problem, because the interaction between threads can corrupt stuff even in Java. Okay, it has to do with doing things in a interlocked way. So one thread can do one little thing, the other thread jumps in and try to access the same object. And so your object is halfway updated by one thread. It's not done yet. The second one jumps in and try to modify the same thing. So that's why we can potentially have issues when you have multiple threads trying to access the same screen object. And then the last one talks about how to do that safely, so that you don't end up with corrupted objects when you have multiple threads trying to update the screen at the same time. And there's a little attachment. It's not an attachment. There's a file that you can download. Multi-threading example one is actually a zip file that you can download. You can unzip it and then import it into your own Eclipse projects. It's a very simple example, but it does illustrate the components that you need in order to have a thread executing quote-unquote in the background that can still update the screen also at the same time. Okay? So we'll go ahead and start with processes and threads, which is really a general discussion of what is a process and what is a thread, and why are those things important in the context of this class. Alright, so we'll go ahead and get started with a process. A process is basically a program in execution, and this is the definition that we are going to use in this class. A process is a program in execution. For those of you who have experiences with Microsoft terminology, a lot of times they change the meaning of well-known computer science terms. Okay, so in this case, we are not going to use Microsoft definitions. This is the definition used by Android developers. It's used by Linux developers. It's also used by most four-year universities. So when they have an operating system class, when they talk about a process, they use exactly the same definition. It's a program in execution. When a program is in execution, it has certain types of resources allocated. These resources include a whole lot of stuff. It has memory space allocated for global variables. It has file handles allocated for standard in, standard out, and so on and so forth. Okay, so there are a lot of different types of resources allocated to a process. So when you start to run a program, it doesn't matter whether it is an Android application or just a regular program in Linux. A process has all these resources pre-allocated by the operating system. Okay. Are there any questions about the general definition of what a process is in the context of Linux, Android, and most operating systems? Okay. In an operating system running in protected mode like Linux and even Windows NT, it keeps a very well-defined boundary between processes. In other words, if you start up a program twice, okay, you can run the same program twice, and you can have two processes, or many processes corresponding to the same program. Okay, these processes cannot easily corrupt each other. Are we understanding that concept? Okay, so let me kind of illustrate what I mean by running the same program multiple times. Okay, I can do that easily in Linux itself. So let me go ahead and start up like multiple tabs in my command line, and then I run a program called ps-af. PS is a program that you use to list processes that are currently running in Linux. And because Android is Linux based, if you can open up a terminal on your Android device, you can actually run this command as well to look at all the processes that are active at this time. So I'm going to run this and pipe it through less, which means I'm going to use a pager, so I can use page up, page down to look at various parts of the same output. So there's a lot of processes it's listing here, but what I'm really interested in is called bash. Okay, bash stands for Born Again Shell, which is basically what allows me to type commands and then the system can respond to it. That's what a shell program does. And you can see that the bash program is started 6 times for hardwired terminals. Okay, these hardwired terminals correspond to actual console terminals that I can switch to by using Alt F1, F2, F3, F4, and so on. Okay, but you can also see that when I use the tab feature inside the terminal, I also start up multiple bash sessions. So these additional ones are corresponding to the additional tabs that I just opened, like a few seconds ago, a few minutes ago. Okay, so what is this really saying? It's going back to what I said a little bit earlier. The same program, which in this case is bash, can have multiple instances of it running. And those instances, each instance is called a process. So a process is a program in execution, but you can have multiple instances of the same program in execution. Like in this case, I have probably close to 10 or more instances of bash running at the same time. But between these bash instances, running instances or processes, they cannot really talk to each other much. Okay? And as a result, they cannot really corrupt each other either. Each one has its own memory space. Each one has its own file handles. Each one has, all of the resources are independent between these processes. In fact, one of the problems when you have multiple processes is how do I make one process talk to the other one? Okay, because the interface is so narrow and so, how should I put it? It's a very narrow and restricted interface between processes. Basically, the only way they can talk to each other is to go through files. Okay? Now, there are special files called sockets and stuff like that, but nonetheless, those are still files. So the only way you can have processes to talk to each other is to go through files. which also means it's pretty difficult for one process to corrupt the other one, because the only way to, it's kind of like the only way for you and me to communicate is by physical mail. Okay, so it's pretty hard. Physical mail. So you can send me letters, and it has to arrive through the mail slot. So it's pretty hard for you to mess around in my house, because that's the only way you can interact with me is physical mail. And it's the same thing with processes. Okay. So that's a quick illustration of what a process is, and you can also run the same command in Android if you have a terminal program installed. So just to continue this sentence here, even if there are multiple instances of the same program in execution, and there are only a few ways processes can communicate with each other and coordinate operations. So for the most part, if you have some logic that you think, okay, I think these logic need to communicate with each other and do a lot of coordination, it may not be a very good idea to separate those logic into multiple processes. So how do you get things to run in parallel when you don't want to separate those into multiple processes? Well, the answer is threads. Okay, a single process has at least one thread. A thread is essentially an execution point. In other words, it is a particular point in execution of that particular program. Okay, and you can have multiple of those things too. The next sentence talks about that. A single process can have multiple threads, which means there can be multiple execution points that are concurrent, quote unquote concurrent, and independent in the same process. Are there any questions at this point? Okay, what you can do is to kind of imagine that a process is like a factory. Okay, so you have a factory setting, and a thread is like a worker inside a factory. So in order for a factory to be functional, you have to at least have one worker to do something. Otherwise, it's just a building with resources, but it's not doing anything. So you need to have at least one worker, which is a thread, inside the factory, which is a process for the factory to actually do anything. Now, you can have multiple workers inside the factory, and they have the same access to all the equipment, all the tools, and all the raw material. Sometimes it's a good thing because in order to communicate between the workers, they can just leave little memos to each other inside the factory. Okay, it's very easy to do the communication. But at the same time, it can also be bad because now you can have workers competing to use the same tool. Okay, I'll give you one example. Okay, so let's say inside the factory, worker A has set up a drill press. Put in a certain drill bit, okay, for a particular job. Okay, set up the height, everything for a particular job, and worker A needs to go to the bathroom. Okay, and worker B comes along and say, hey, you know what? I need to use the drill press too. So worker B, not knowing that worker A was using a drill press, will change all the settings, change the drill bit, change the height, the depth of drilling and stuff, and so on. And worker B will do, okay, I'm done with this. And then when worker A came out of the bathroom and go back to the drill press, worker A is not aware that worker B had messed around with all the settings and also the drill bit. And now worker A, resuming his or her job on the drill press, will use the wrong drill bit and the wrong settings to continue what he or she was doing originally. Okay, so that's the problem of multi-threading, because threads can share resources just like that. Okay, because everything is visible to everybody, so they can mess around with the stuff of each other all day long, and you can have problems now. Okay, now what about communication or coordination between processes? Well, to communicate between processes or between the factories, you can only rely on, let's say, in good old days, fax. Okay, facsimile. That's the only way you can communicate from one factory to the next. So you cannot really quite mess up something in another factory just by sending a fax to the other factory. That's analogous to the communication between processes. But inside the same factory, which work between the workers, the threads, bad things can happen because they really share everything: memory space, file handles, everything that is usually allocated to a process. All the worker threads can access the same thing at the same time. Okay, so that's why we have potentially an issue here. All threads of the same process, okay, all workers in the same factory in the analogy share basically all the same resources except for something that we call the execution stack. The stack is what you need in order to do function calls, and that part is the only part that is individual to each thread. But everything else are shared. Okay? Which also means in Java, remember in Java, all your objects are referred to by references. So now you can have different threads to have references to the same object in memory. And if there's no coordination, then you can end up with the same problem that I just described. One thread can start to modify the referenced object, and because of timing, that thread decides, okay, I'm gonna do something else. Okay, I will let somebody else get the execution time. The next thread comes along, not knowing that object is already being modified or halfway modified by another thread, will just go, okay, I'm gonna do something to this particular object. When the original thread comes back to the same object, it doesn't know that that object has been modified by a second object, and now we end up with a problem because it's a corruption issue. Are we doing okay so far with these concepts? Okay. Now, one stack is required for each thread, and for the most part, you don't have to worry about, okay, how do I allocate a stack for a particular thread, because that all can be done automatically by creating threads. Threads of the same process can communicate very efficiently because they share the same memory space along with all of the other resources of a process. However, this also means that without proper coordination, threads of the same process can also easily overwrite memory content of each other, causing symptoms that are very difficult to debug or to diagnose. The problem has to do with what you see due to the corruption of objects has to do with the interaction or the interleaving of execution of these multiple threads. But that part is not deterministic. Okay? So I'll give you a picture of what I mean by that. Two colors are required for this picture. Okay, so let's say you have thread A and then you have thread B here. Thread A executes a little bit, and then and the operating system is responsible to basically say, oh, thread A, you have executed for 5 milliseconds. I think it's time to give up control for somebody else to execute. So the operating system can preempt thread A and say, okay, you got to pause here, which is okay. I mean, that's not a problem. And then the operating system can pass the control or the right to use the processor to thread B of the same process. So now thread B executes a little bit, and then the operating system can basically say, okay, it's now time to pass control back to thread A to continue execution. This by itself is not an issue. What is an issue is the timing. Okay, so even if you run the same application, you start it up exactly the same way, because of other factors, like everything else that can be happening, the timing of this transition and the timing of this transition can be different. And in fact, it will be different every single time. So that means, if this timing has something to do with which part of the program is modifying a shared object, that also means the corruption or the corrupted part can be different every single time. And as a result, the symptom that you're seeing from the outside of the application can also be very different every single time. It is also possible that the timing is very unlikely to happen. In other words, your program is not exactly safe from these kind of corruption problem, but the overlap time that actually can make this happen is really narrow. So you may not have a problem for an entire year, and then the program crashes in a certain way. Okay, you wait another year, the program will crash, but in a slightly different way. And you wait another month, and then it crash again. It's completely unpredictable when it will crash and how it will crash, even though it is coming from the same source of problem. So I'll be okay with that concept because it has to do with the timing and the interaction between the threads. Okay, this is the worst kind of bug you can get. Okay, because it is not consistent. even if you have a regular type of memory corruption problem, let's say in C++, which is notorious for memory corruption issues, as long as the program is doing exactly the same thing every single time and it has the same symptom every single time, it is still relatively easy to debug. This is difficult because you cannot rely on the program to do the same thing every single time, just because of timing. Are we doing okay so far with the concept of multi-threading issues can be very difficult to debug and diagnose? Okay. Now the nice thing is the Android API application programming interface provides many methods to make thread interaction safe. This is important because there is quite a bit of complexity to help threads of the same process to make use of shared resources properly. So for the most part, the Android framework as well as Linux supplies a certain number of tools for you to use to make multi-threading safe. The communication between processes is also supported by some Android APIs. It's called a remote procedure call. However, the main issue of most inter-process coordination is that the interface is too narrow, too well-defined, and too inflexible, and opposite to the interface between threads being too general and flexible, and it causes issues. Are there any questions about this slide? Okay, any questions about the concept of what the process is, and the concept of what a thread is, and also the concept of why multi-threading can be problematic, because they can try to modify the same thing at the same quote-unquote at the same time, and the interleaving of all those operations is unpredictable. So if you don't take care of those things, the program may seem to work inside a debugger, maybe inside an emulator, but when you actually deploy it onto a device, it may not work the same way. Okay, it may crash and not crash the same time every single time. Yep.
I think you should add that factory analogy to the text.
Ah. I just thought about it when I was using the bathroom today. Note to self, right?
Coincidence, or did something happen?
I have to use my cell phone in the bathroom to take note. All right, so that's any questions about this one?
So is there a distinction between threads versus like multitasking, or is it the same concept?
Between threads and
multitasking.
Multitasking? That's
the terminology.
Multitasking is from the end user perspective. The apparent ability for you to run multiple programs at the same time is quote unquote multitasking.
Yeah.
How it is actually implemented is irrelevant for the term multitasking. Threads is a very specific term in an operating system, and so multi-threading has a very specific term. A multi-threading program may not be seen as a multitasking kind of thing, because a multi-threading process can be a server process, so it has no direct user interface, and as a result multitasking does not apply to that particular case.
Well, there's the terminology of preemptive multitasking versus non-preemptive multitasking.
Correct.
Right, and so Android is a non-preemptive with a single process, right?
No, Android uses Linux as a foundation of an operating system, and Linux itself is preemptive.
Linux itself is preemptive.
Yeah.
But preemptive between processes, but between thread is non-preemptive.
It can also be preemptive. In other words, if one thread is have a tight loop and do something, the OS, the kernel, can actually kick in and say, okay, it's time to give up control for other threads to have some execution time.
Okay,
So it's preemptive from that perspective, but preemptive also has different types of meaning when it comes to multi-threading and multi-processing. Because the concept of preemptive only applies to threads and not necessarily to processes. Because one process can have multiple threads, so when you have multiple threads inside the same process, which one are you preempting?
Wait, multiple processes. Wait, repeat that question.
Okay. when you talk about preemption,
Yeah.
you're preempting a thread and not preempting a process.
Okay.
So that's why the concept of preemption always applies to threads and not really particularly to processes.
Okay.
All right.
Is it because you're saying that a process is executing a thread?
Right, because the only thing that makes a process do something is a thread.
That's it. Okay.
Yep. So that's why the concept of preemption, which is basically saying okay, stop doing what you're doing because you're hogging all the processing time, and let somebody else get some processing time. That concept only applies to a thread and not a process. Now, when you have multiple threads inside the same process, it still applies. Basically, if you have a tight loop, with one thread, you can say, okay, it's time for you to give up control, so that other threads, maybe in the same process, maybe in some other process, can get some execution time. In fact, we can look this up just to be sure. So Linux preemptive threading. Okay, so we'll just look up these terms. Preemptive threads versus non-preemptive thread. And this is overstack. This is in Stack Overflow. Can someone please explain the differences between preemptive threading model and non-preemptive? So that's why you can see that preemptive applies to threading and not, a process. And it also explains here, a non-preemptive thread typically manually yield control to let other threads run before they finish, which is a very, very archaic way of doing things, and is definitely not recommended. This was necessary in the good old days. In other words, in the good old days of Windows 98, 95, and before. So in Windows applications, there's no kernel, there's no quote-unquote real kernel when it comes to Windows 98, 95, and everything before that. And as a result, no one can step in and say, hey, TAC, you have been hogging too much time, using the processor. It's time to let somebody else, get some execution time. And as a result, all applications during those time, they have to say, I have to give up control voluntarily for some other process to actually get some execution time. But the anti-kernel is different. The anti-kernel can manage threads and say, okay, this thread has been executing for 5 milliseconds already. It's time to give up control and let somebody else run. So as a result, the concept of yielding control in the thread is no longer necessary. Now, most programs or most environments do support yield, which is basically saying, okay, I'm being nice, okay? I don't really have anything else to do now. Let somebody else get some execution time.
Like if you're waiting for a resource, for example, like an IO or whatever.
Not so much. If you're waiting for a resource, it is called a blocking call.
Yeah.
It means when you perform a system call and that resource is not available at the time, it would actually put that thread to a suspended state, into basically a queue waiting for that resource.
Right.
So until that resource is available, this thread remains dormant. Basically, it is just not doing anything.
But when you give up, you don't run a pipe loop, right? You give up your CPU to some other thread.
We can test this, when we get to the programming part to see whether it is actually preemptive or not. Because I know it is preemptive, but we can double check in.
Or do most OS provide both mechanisms, both preemptive and non-preemptive?
Most modern kernels are preemptive.
But for example, if you're waiting for a resource, then you're not.
Right, because when you are waiting for a resource, it will do a blocking call. So the thread that is waiting for the resource is automatically stopped. It doesn't take up any more execution time until the resource becomes available.
But it allows other threads to run, right?
Yes.
So is it non-preemptive also in that sense? Non-preemptive to me is when you give up the CPU and allow other threads to run.
Okay, the concept of whether a kernel is preemptive or not applies to the kernel itself, not the application.
Yeah. Yeah, so what I'm saying is there's mechanism within, yeah, I think, well, when it says here for non-preemptive, when you manually give up, it's usually when you're waiting for a resource, you're giving up the CPU because you're waiting. So
no, but when you're waiting, you don't have to use yield. Yield is basically just saying that I'm voluntarily giving up control, so that somebody else can get execution time. But I'm not really waiting on something. If I'm waiting on something, I should be using another mechanism to put myself into a suspended mode and say that I'm waiting for this resource here, but until this resource is available, don't even bother to give me any execution time. Yield is basically saying, okay, I'll give somebody else, execution time, but when it's time, come back to me and give me execution time as well. I'm actually ready for more execution time. I'm just being nice to let somebody use the execution time of the processor in the meantime. Okay. All right. So now we're going to talk about the UI, or the user interface thread. This is a pretty short slide, but it is important nonetheless. The UI thread, or the user interface thread, is the first thread that is created in a particular application, in the process of a particular application. It is also sometimes called the main thread because that is the thread that gets started when you start an application. When you have an application that has a user interface, such as an activity, this is the thread that is going to deal with the looper, which is the loop that gets a message out of the queue and then dispatch the message and so on. After initialization and starting up, this thread enters a message loop where it sits. Basically, it's in a blocking call. It uses a blocking call to basically say, I'm not going to do anything. I'm not going to use up any processing time until there is a message for me to dispatch and process. Okay. So if nothing is happening after you start up an application, it just sits there doing nothing. It's not going to use up any processing time. When there's a message available in the queue, then it will grab that message out of the queue and it will dispatch the message. And when we say dispatching, it's basically just running through a huge switch statement conceptually, running through a huge switch statement, figure out which object is supposed to get that message and handle that particular message. Okay, but these are all being done in the same thread. Okay, so we have one single thread that is responsible to say, okay, I'm waiting for a message. Oh, here's a message. Let me read the message here. Oh, okay, I see that this is intended for that particular view item, view object over here. And then it will go to that view object using the same thread and say, okay, you need to process this. Okay, somebody just touched this particular view, and do whatever you need to do with that touch event. Okay. Now, when the view is dealing with that touch event, the view can also say, okay, I need to update this, that, and whatnot on the screen. Each request to update those objects is actually putting additional messages back to the message queue, so that this loop, when it comes back, it will grab the additional messages and say that, oh, okay, so and so object, you are requested to update yourself on the screen. Okay, repaint yourself on the screen, draw yourself on the screen. And that's why the on-draw method is important, because it is basically saying, okay, what do you need to do when somebody is asking you to redraw yourself on the screen? That's what the on-draw method is about. So this is the main thread. This means that all actions performed by such an app are triggered by the reception of messages. Okay, because of the message loop construct. If you want an app to do something, you have to somehow give it a message to process. When you click something on the screen, the Android framework is responsible to send a message to this particular thread, so that it will just unlock from itself. It will basically unthaw. It will thaw itself from its suspended state and go like, oh, here's a message. Somebody touched something on my screen and I need to do some processing. Okay. Other applications, other processes can also send messages to a particular process. So the rest of this paragraph is really just an example, of what kind of messages can be generated. Some can be from outside, like somebody touching a screen, and others from inside, which is a particular object saying I need to update that, and also that. With a single UI thread, single user interface thread, most typical user interactive apps can be implemented. So this is okay. This is single thread model is okay for most applications. When I say most applications, I mean applications where the user would touch something on the screen, trigger some kind of operation, and then when that operation is done, the application is coming back and saying, okay, what else do you want me to do? I'm just going to sit here and wait until you tell me what else you want me to do. Okay, so there's nothing that needs to happen between the user actions. Okay, well, how about games? There are certain games that kind of operate this way. Like if you want to play a chess game, for instance, and the opponent is the computer itself, this falls into that category, right? You make a move, and then the computer will respond to your move. And then the computer would just sit there and say, okay, how are you going to counter this move? And it can just sit there for eternity until you say, okay, I want to move this piece to here. Okay? But what about other types of games? What about, say, Angry Birds? Okay, what are the user interaction with Angry Birds?
Touchdown.
Okay, how many people have not played or seen someone play Angry Birds? Okay, Angry Birds goes like this. Okay, I'm just gonna use that as an example. Angry Birds is really just a recast of a classic game of slingshots, shooting something. So you basically have a bunch of pigs over here. Okay, so you have a bunch of pigs, with like usually they're under a building or something like this. And then you have a angry bird on this side. They're angry because what is the background story? The pigs
Stole the eggs.
Stole the eggs of the birds. Okay, so you have angry birds here, and the birds are cute. They're huge heads and little feet and little wings. And then the way it works is there's a slingshot. So there's a little slingshot here. Okay. And the way it works is you drag the bird backwards using your finger, using a touch motion, so you can control both, how strong you want to shoot it, and also the angle you want to shoot it. Okay, and then as soon as you release the touch, it's kind of like releasing, a slingshot. So the bird will be, propelled by the rubber band, and it will have there's a physics engine to let gravity do its work. So you have a trajectory. The bird will basically fly and land on wherever it's supposed to land on. And then these blocks, they also have the physics engine, so you can basically it will shake and it will fall apart. So if something falls on top of a pig, the pig quote unquote dies, and then you have to kill all the pigs within the same scenario to move on to the next one. And you have only so many birds you can shoot for each scenario. So is that a reasonable summary of the game? Okay. Now, if you get the Star Wars edition, then you have strange physics too, because you can shoot birds in outer space. So you can actually, do really weird stuff, with these birds. With certain birds, like they have birds corresponding to Yoda, to Luke Skywalker, and so on and so forth. So with those birds, when it's landing on the other side, you can also click on the bird itself to trigger whatever the special move of the bird is. Like I think with Skywalker, he can kind of like do his lightsaber thing to kind of knock out things, after he lands, on the pigs. So with certain ones, they can shoot. I think some can shoot too. So that's how the game goes. Okay. But getting back to our topic here, would the single thread model be okay for this type of game? In other words, your interaction stops for the most part after you release the touch and let the bird launch itself. Okay. So what is going to keep the update of the bird as it is in flight going over to the other side? There's nothing, right? Using a single thread model, there's nothing that can trigger your application to keep updating the screen or even the coordinates of the bird while it is flying over to the other side. Because you stop interacting with the application as soon as you release the button or release the bird, so it can release the slingshot basically. Is that making any sense? So the single thread model is not suitable for this type of game because after you release the bird, then it will just stay there. Nothing is going to ask you to trigger your application to say, oh, okay, we need to keep track of the time, and as time goes on, I need to update the coordinate of the bird, and so on and so forth. There's nothing that can trigger that logic. Are we doing okay so far with that concept? Okay. Now, you can actually set up certain things to basically cause a thread to quote unquote call itself. You can post a message to itself so it can wake up itself, and then you can do a wait and then do something else. But it's not really the best way of implementing something like this, where you need a background process to actually do some computation and screen updates. Now the single user ID model, the single user interface thread model, is not suitable for apps where constant updates of parts of the screen is needed, okay, such as the Angry Bird games. This includes most games, augmented reality, and other apps that require constant update to the screen. Okay, with an augmented reality app, you start the application. Now what happens? Okay, you're just pointing that thing in different directions, right? So how can your application keep updating on the screen and say, in this direction there's a restaurant in 5 miles, in this direction we have a gas station in 10 miles, and so on? What is keeping your application updating all these things constantly while you are doing nothing? Now someone might say, well, because I'm moving, right? Because the sensor, the compass and the sensor can sense these events. What if you're just sitting here, propping it up and doing nothing? It's still constantly doing something, right? So how does that action get triggered when you are doing nothing, absolutely doing nothing? Okay, so the key is in the next document. The next document talks about how to share the screen amongst multiple threads. For applications that require constant screen updates, it makes sense to make use of multiple threads. In other words, you still have your typical user interaction thread, the UI thread, which is still using the looper concept. I'm waiting for a message. If nobody tells me what to do, I'm just going to be here sleeping, okay, doing nothing. Okay, that is still how the UI thread is going to do. It's just sitting there saying, okay, I'm going to wait for something to happen. If no one tells me what to do, I'm going to doze off and sleep. But in addition to that thread, you have a secondary thread that can be constantly running all the time. So in the game, one particular thread can keep track of the trajectory of objects. Like in Angry Birds, you can have one thread that is responsible to keep track of this particular object and say that, okay, by a certain time it should be here on the screen, by a certain time it should be here on the screen, and so on. Okay, so you can have one thread that is doing that, doing constant update of the object. But the problem is, what about when the thread that is responsible to track the object says, okay, it's time to update the screen, who is going to update the screen? You have two threads now, okay? So one thread is the user interaction thread, the UI thread. I'm looking for my marker here. Okay, so you have two threads. One thread is, okay, in this case we have two threads that are executing quote unquote in parallel. So for all practical purposes, A and B are running in parallel. So A is the UI thread and B is the game thread, which is implementing the tracking of the trajectory and so on. So A is basically running, most of the time is sleeping, doing nothing. The B thread is constantly running because it has to keep track of the trajectory of the bird, Angry Bird, and it has to kind of do all the screen updates. But the problem is, thread B, which is responsible to redraw that bird all the time, cannot do that. It cannot have access to the views, cannot have access to the screen, cannot have access to the activity directly. because that really is the job of thread A. Okay, so the question now is, how do we do this coordination? Okay. The problem has to do with the UI classes, the user interface classes. What kind of classes are we talking about, user interface classes? Well, if you look up, Android and just about anything, okay, anything that is under view, the view class. Okay. So Android uppercase view, that's a package, but I want the class view, interfaces, right there. Okay, so if you look at all the subclasses of view, basically there are 57 of these things. If you want to do anything with these particular things, it cannot come from thread B. Thread B is not allowed or should not be dealing with these objects directly. Okay, because getting back to my notes, it has to do with these classes are not designed to work with multiple threads. It's just really as simple as that. Okay, Android never, as a company, never designed these classes to be used by multiple threads at the same time. Okay, so why do you think they are not designed to work with multiple threads from the get-go?
Because there's one screen.
Well, there's only one screen, but you can have multiple threads, in one single application. So one way to solve the problem is to make all these classes what we call thread safe, which means they are designed to work with multiple threads at the same time. But that would make it inefficient. Okay, you can protect objects so they can be you can use those from multiple threads, but it's inefficient. Okay, so instead of putting all the overhead to make these classes thread safe, Android is using the other method. Okay, it's basically saying, okay, if you have multiple threads and only one screen, and these other threads, only one thread can update the screen, what we'll do is we'll coordinate the execution of these threads. Okay, so in the end, you still only have one thread that is responsible to update the screen, but other threads can tell this guy what to do with the screen. Okay, is that okay? In other words, getting back to the factory example, okay? Getting back to the factory example, now you have a worker, which is a thread, whose only job is to work the drill press. Okay? So I'm the guy, next to the drill press, and I'm the only guy who's supposed to touch the drill press. So what about you and you and you? You have stuff that you want to drill. So what do? Well, I cannot give up my drill press to you, but you can submit a job to me. Okay? So you can put your stuff to drill on a little cart with instructions like I need this kind of size of a hole here, and it has to be drilled this deep, and so on. So you guys will line up your cart with the stuff that you need to work on with a drill press, and I'll just be here going like, okay, who's next in line? I guess you're next in line. I take your cart and I look at the instruction and go like, okay, I guess you want 30 holes drilled with this bit, and the locations are here, here, and here on this object. Fine. Okay, I will put your object on the drill press. I'll do my job. When I'm done with this one, I pass it on, grab the next truck or the next cart, do the same thing. What is that line of carts called in the stuff that we have just talked about? Or what is each cart? It's a message. Okay? It's a message queue. Exactly. That line of carts waiting for stuff to be drilled is the message queue. Okay? So each message is a job that I need to do, and I'm the only person with a drill press. The drill press, in this case, is corresponding to all the user interaction stuff that you can display on the screen. Anything that the user can touch, can see, that would be the drill press. And I'm the UI thread. I'm the only guy who's supposed to work with that. But you guys can tell me what you want to do with the tool itself. Is that working out okay? So that means, for the most part, you guys can still do what you want to do individually and independently. Okay, so you can basically do whatever you need to do, weld, polish, and whatever. Okay, it's only when it comes to having to drill something on the product that you need to come to me and line up to get your job done. Are we doing okay so far with that concept? Okay. So that's basically what is happening here. Because, well, this part we have explained already. Having multiple threads where execution point can interleave to access UI elements without coordination can lead to mysterious corruption. It's basically the example getting back to, having the drill press open to every worker in the entire factory. And, if someone is halfway done with a job, go to the bathroom, the other guy comes in and mess around with the drill press, this guy comes back from the bathroom, and it's like everything is messed up, right? The settings are all wrong, except the worker does not even know it. So we'll be using the wrong tool, the wrong bit, and so on. All right. So this whole thing just kind of repeats the part that I have talked about over and over again of why you can only have one thread responsible to deal with user interaction stuff, and then the other threads, which are also necessary for games and other things that requires constant screen update, they need to somehow coordinate with the UI thread and say, hey, I know you're the only guy supposed to touch the drill press, so I'm gonna submit a job and say that this part needs to have certain parts drilled, and this is how to do it, okay? And I'll just wait for my job to be done. Are there any questions about this analogy? No questions? Okay. If there are no questions about this, the next slide is going to be the only one that is that has Android specific information, and here's an example of that program. So now we're getting into actual multi-threading. And when you're actually trying to use multi-threading or using multiple threads in the same application in Android, you have to understand a few things. The first one is called a runnable, and this is an interface. It's not a class, it is just an interface. This is what we need to pass, this is the type of something that you can use to pass objects around, and it's just called runnable. It's very simple. A runnable interface only has one single method to be implemented. It is the run method. Okay, that's it. You specify a run method in any class. Objects of that class can now be passed using a runnable interface. Are we doing okay so far with that concept? Okay. The next class is called a thread class, and that's why this one has an uppercase T, because I'm referring to the class thread and not the general concept of threading in operating systems. A thread object represents a particular thread. It includes a stack that is required for a stack to run, and many other methods to interact with other threads. I'm not going to get into the other to the interaction part of threads. Basically, one thread can join other threads. You can basically say, I'm not going to proceed until this thread, and this thread here are also done. So you can merge multiple threads back into one. You can split up. Okay, you can say, I'm going to spin up multiple threads starting at this point. So you can do all kinds of coordination between the threads. I'm not going to talk about that too much here. A thread object, or the thread represented by a thread object, does not actually become a system thread until the start method of this particular thread object is called. Now, this will all be demonstrated in an actual program, so don't worry too much about, okay, but where do we put this call? Who's going to call it? We'll answer all those questions later. Now, this part has to do with when you read the documentation on the thread class using the Android website, you have to understand which thread is being described by a particular statement. A method of an object is always called by a thread, okay? Because a thread is the only mechanism that can maintain an execution point. So when you're calling something, it is a thread making that call, okay? So this is called, I call this the caller thread. Basically the thread that is responsible of invoking the method of something. The called thread, the called method, assuming it is non-static, can be a member of a thread object representing a thread. So this particular thread, which is represented by the invoked thread object, may or may not be the same as the caller thread. Okay, this looks awfully confusing, doesn't it? Okay, so let's take a look at this example here. We have thread A being the user interaction thread, and thread B, which is the game engine thread. Okay, so each one is represented by an object. So we look at A and say that, okay, this is represented by an object. Then we look at these, thread B, it is also represented by an object. So the question now is, how does game B, okay, thread A or object A has methods. Object B also has methods. So let's say object A has a method called M1. Okay, so it has one particular method called M1, and it is a non-static method. Because I have to emphasize it is non-static, because a static method belongs to the entire class. So you cannot really say which object's method it is. So this is a non-static method, which means this method will do something specific to object A. So let's say somewhere here, game B, object B, which is also a thread. This particular thread is calling this method and saying, hey, object A, I want you to perform M1. Okay. So in that scenario, this thread is the calling thread, and this one is also known as the receiver thread. Okay, because it's receiving the call from the other thread. So when you read the documentation, you will actually see those terms, referring to the calling thread and the receiving thread. Okay. So moving on, this is really just making sure that you know how to read the documentation, on the Android website. A thread object containing other object that implements the runnable can contain another object that implements the runnable interface. So there are two ways to specify what to do when the thread starts. Okay, you can either override the run method itself, or you can give the thread a runnable object where the object itself has a run method implemented. So there are two ways to do this, and it's up to you to decide which way you want to do it. Interacting with the UI thread, the Android document explicitly states that only the UI thread, the main thread, should handle any type of UI objects. So your own thread, your other threads really are not supposed to do anything about drawing stuff on the screen and processing events. Okay. So what happens when a non-UI thread needs to update the screen? For example, in a game, you may have one thread that keeps track of the path or trajectory of a particular object. When the position of this object changes, this thread, which is not the UI thread, needs to update the location of the corresponding object on the screen. So what you can do is one of these three methods. There's one method called run on UI thread. That's the name of the method. It belongs to the class activity, and you have to pass it a runnable object. Okay? So this is one way to do it. You basically specify what needs to be done, and then you pass it on to the UI thread and say, hey, UI thread, I want you to do this. You're basically constructing what is a runnable here is analogous to the instruction on the little card that you are lining up next to the drill press. Okay, because that's telling me what to do. So runnable is the instruction of the little card with stuff that you want me to drill, so that when I get to your message, I know what you want me to do. Are we doing okay so far with that concept? Okay. So that's one way to do it, and to use this particular method, you have to know the activity that is running, that is being controlled by the UI thread. You can also use the post method of a view, or post with delay of a view. So depending on which one is more convenient and you have access to, you can choose one of these three ways to specify what to do. The parameter of post is just a runnable. The parameter of post delayed is runnable, followed by a long integer to specify the number of milliseconds to delay in order for the runnable to execute. So you can basically specify a delay. In other words, in a shopping cart, you can say, don't process this part until 5 o'clock. Okay, so well, it's not exactly specifying when to start. It's specify delay. So you're specifying, okay, I don't want this job to be done right away. I want this job to be done like 5 minutes after it is submitted. Yep.
And that's just a minimum delay.
Like a 0?
No, I mean like 20 milliseconds it'll run 20 milliseconds or a little bit after that.
It is not completely accurate. There's no guarantee of the actual timing. So it's going to be approximately 20 milliseconds, but there's no guarantee of how close it can be to 20 milliseconds. That's according to the documentation. So according to the documentation of post-delayed, it is only a quote-unquote suggested time. So it will delay approximately that many milliseconds, but not necessarily very precisely. So I wouldn't use it for timing purposes, but I would use it to say, okay, approximately in 20 milliseconds, we need to refresh the screen so I can repaint the Angry Bird in flight to the destination. Okay. So to tie everything together, okay, here are some questions, FAQs. Who is starting the UI thread? Well, the Android framework is doing that. So you don't have to do a single thing to the UI thread because it is automatically started. By the time, quote unquote, you have control, like on create, it is already running the UI thread. So don't worry about UI thread, it is already there. Who creates additional thread objects and start the associated threads? Remember, uppercase T refers to the type or the class. Lowercase t refers to the concept of a single thread. There's no limitation as to when thread objects can be created, because when you're just saying new thread, open and close paren, you are just allocating the memory space and also initializing thread objects. But it does not actually start to do anything. There's nothing that is running at that time. You're just creating an object, and that's all that you're doing. But before you invoke or call the start method of a thread object, you better make sure that the resources needed by that thread will be present. In other words, you don't want to start a thread that might want to update the screen in onCreate before the superclass is onCreate. Because before the superclass calls onCreate, you may not even have those necessary views and whatnot available on the screen at the time. So you got to make sure that everything is available on screen, already loaded, before you start a thread that relies on those particular items. That's basically what the next sentence is saying. Passing a runnable object to a thread constructor. Should I use this method, pass a runnable object to a thread constructor, or should I override the run method in a thread subclass? So these are the two ways you can specify what a thread is supposed to do. So the answer depends on, okay, here's the answer. If the logic of threading requires, thread non-static methods, then you want to override the run method of a thread class, because that way you can access all the non-static methods of a thread. Otherwise, either method can be used. So this is a good time to kind of do a quick look at what you can do with a thread object. So we'll go take a look, and the first link is the proper one. So we'll take a quick look at what you can do with a thread. And so we have constructors. You can construct a thread using the default constructor, which basically says, I'm just creating an object here, and not, it's just an object. You can create a thread with a runnable, which basically means, when this thread is started, whatever you pass as the runnable is going to run. You can start a thread with a runnable and a thread name. Okay, basically you're just naming a thread, and you have variations of this. And the most important one is, okay, I guess not. It's not specified here, so it's not one of the constructors. So your choices, your main choices is really, do I want to start a thread without passing a runnable, or do I want to start a thread with a runnable? There is no way to attach a runnable after the constructor is called. So this is the only place. If you want to pass a runnable, the constructor is the only way to attach a runnable to a thread. Okay? A thread group is basically a way to group threads together so you can apply group operations to an entire group. And these are the methods. Active count returns the number of active threads in a particular group. Check access does nothing. Okay, so I have no idea why they have this method, which doesn't do anything. So you have multiple things here, and you can see that certain methods are static. In other words, with current thread as a static method, when you call current thread, you do not say, in this case, a dot, current thread. You don't say b dot current thread. You just say uppercase thread dot current thread, because this method applies to the class and not a particular object. What it does is it returns the current thread or whatever thread that is calling current thread. Now, why is it useful? Well, this way you can actually access the thread object-dependent, the non-static method, using this particular method. You have destroyed, it is deprecated, not implemented, so don't even bother to call it because it's not implemented. Dump stack and so on, get all stack traces, get ID, it returns the thread's own ID, and so on. So some of these most of these are not static, which means they apply to a particular thread object and not to the current thread. Join operations, we kind of talked about this a little bit. It allows you to have multiple threads to come to the same execution point, and then all of the threads will disappear except for one to proceed after this point. Okay? I'm not going to spend too much time to talk about these ones, but it is important to talk about run. Run is a particular method that applies to a thread object. When this is called, it will in return call the run method of the runnable object that the receiver thread is holding. Now, the only way to specify a runnable object is through the constructor. So what if the constructor is not being passed a runnable object? Then your only option is to override this particular method to specify, okay, what do we do when this thread starts to execute? And the other one that is kind of useful is sleep. Because sleep is a call, and once again, it is a static one, which means it is applied to whatever thread that is making this call. Sleep basically says whatever thread that is calling this method can basically suspend itself for approximately this number of milliseconds. So you can basically say uppercase thread dot sleep 500. So that will basically put a delay of half a second to whatever thread it is calling the sleep method. So this way you can do a little bit of timing if you want to using this particular mechanism. You have start, which is the most important one because this is the one that actually starts a thread to execute. You have stop, suspend, to string, which is a way you can quickly kind of return the string to have a concise description of a particular thread. It's good for debugging purposes. And we still have yield here, which basically means a particular thread can be nice to other threads and say, okay, I really don't need this much processing time. I'll let other people have a chance to execute. But it's not really needed. I think it is preemptive, so that's why a yield is actually not needed in the multi-threading model here. All right. Are there any questions about this kind of brief description of methods that you might find useful when you're doing multi-threading? Start, run, sleep, those are the most important ones. What is the minimum number of objects to create for a non-UI thread to update the screen? So if I want to write an app that uses a quote-unquote background thread to do some computations, and that thread occasionally will need to update the screen, what kind of object do I need and how many do I need? You need one thread object or a object that is of a subclass of thread to represent the non-UI thread. Because when the Android framework starts your application, it only starts the UI thread. So anything that is not a UI thread, you are responsible to start those threads individually. You also need a runnable object. In other words, you need to, in the cart that contains the part to be drilled, you need to give me the instruction of what to do. That is basically a runnable object that you're going to pass to one of the three calls. It is also listed here. Run on UI thread, post, or post delayed. Each one of those will require at least a runnable object, which is the instruction of okay, what do you want the UI thread to do? That's what the runnable object is representing. Are there any questions at this point? No questions? If there are no questions, I'm going to do a really quick example. You can actually download it from the Moodle website also. This one, if you click it, it will download a zip file. Unzip it into whatever folder you want to unzip it into, and then inside Eclipse, you want to import that folder into your Eclipse project. Then you can have access to that project. So we'll go ahead and do a really, really quick run of an example. And I can do it interactively so that you guys can see the process of doing it and not just the end result of this. So I'm just going to call this test thread here. And I will keep com.example. It's just not going to spend the time to refine that. Great. So now we have a fairly simple basic template application called a test thread here. But the first thing I want to do is to make sure that I know how to refer to this particular view object. So I look at this, and I want to look at properties. It doesn't have an ID yet. So the first thing I want to do is to associate an ID with this particular text view. It should be called text view 1 now, inside the resource file. Save all the files. Okay. And that's all I need to do as far as resources are concerned. Now I can go back to the source code. Oh, okay, it doesn't like that. It's complaining that it's not string type not allowed at ID with value is. Okay, so it wants to use at ID / text. There's a plus sign that they need to put somewhere. Like that. I can't remember the syntax to define an ID. I think this one is correct now. Yep, it is. It's okay now. So I have to remember the syntax is to use it. Okay, let's see. The plus means define it if it doesn't exist yet, but it is called text view 1.1. Okay. But the main point is to get back to the source here, go back to main activity. And we'll go ahead and define what we need to in order to make use of multiple threads. Right, so here's onCreate. Okay, I can hide the other one at this point. So here's onCreate, and I want to start the helper thread here. Okay, and the way I want to structure the helper thread is to create a subclass of a thread. Now in Java, you can do this. You can basically say, I'm defining a private class inside a class definition. So this class, is only known to main activity, and it can only be used inside main activity. It cannot be exported to somewhere else. So I'll call this, my thread extends thread. Okay. And it's going to say that it's not being used, anywhere, but that's okay. Okay, we'll just do it like this. It's going to have a public method returning void, and it's called run. And then the other thing I need to do here is to say override, because this way I let the compiler double check to make sure that my run method fits all the same requirements as the run method that I'm overriding. So in this case, I just wanted to keep track of a counter. So inside main activity, I'm going to use a particular counter here. And in onCreate, I will initialize counter to 0. Counter equals 0. And inside of my run thread here, it's going to run an infinite loop. So I would say while true, because that's an easy way to make an infinite loop in Java. And what I want to do is very simple. Okay, I just need to sleep. Okay, so thread.sleep. Let's say every 100 milliseconds or every 1 second, I'm going to do something. What I will do is I'm going to do a increment counter, and I want to update it too. Okay, so I will talk about how to update it later. This part has to do with it's in red because when I use the sleep method, it is supposed to be surrounded by a try catch block because I can throw an exception. So that's why I have to catch it use a try to do something like this. If it throws an interrupted exception, then I will have some way to catch the exception and say, okay, if this exception is thrown, I'm going to do this. I can also kind of ignore this part and like remove this statement here altogether, but that's not going to be a main issue here. The other thing I need to do is to define another private class, and this time is called what to do. Okay, I'll just call it what to do. It extends, or implements, sorry, it implements the interface called runnable. And it complains about add an implemented method because it's implementing a particular interface. So I will just let the tool to get me the run method that I'm supposed to override in runnable. And the only thing I need to do in this case is to update the text view to the number. Okay, but since this thing has no visibility of the text view, I need to somehow expose it. So what I'll do is to have my text view TV here that I can access in the inside. This is complaining because I have not imported text view from widget, so I just need to click that, and now it's automatically imported. So inside here, I need to specify the logic. What am I supposed to do when this particular object is run? So when this object is run, when the run method of this object is called. So in this case, all I want to do is to update it with the new value of counter. So I'm going to do a TV dot set text, and I want to update it with counter, but that's not going to work because counter is an integer. So what I need to do is to convert an integer into a string, and that can be done by the integer classes method called toString. And now I can pass the actual integer to be converted. In this case, it will be counter itself. All right? Yep.
Would it be acceptable to do a string.getValue?
String.getValue. No, that's the other way around.
Oh, well, it does work.
Oh, it does work?
Yeah.
So it does the same thing?
Or value of.
Oh, value. Value of is changing the string to an integer. So this one changes integer to a string. All right, so we're almost done here. All that is left to do is inside the thread, after I increment the counter, then I have to tell the TV post. Okay, now I need to specify the runnable object here. So I'm going to say runnable R. And now I can say r.post, TV post, and then in here, specify R, and the semicolon at the end. And then onCreate is responsible to create all those objects. So I better make sure that R is created here. So R is new, not runnable, because runnable is an interface. I cannot use that. But I do have a class that implements runnable called whatToDo. TV is a pointer or a reference to the text view object. So this way I need to use a text view as a cast, and then use find by ID, find view by ID, and give it r.id.textView11. Semicolon here. Let's see, and I need another one for the object, for the thread itself. At this point, I'm ready to start the thread. Okay, the thread can start existing right away and start running right away. So with this one, what I can do is I can say new, okay, to allocate for the object first, and I have my own thread as a class name. So I'm creating my own thread here, and right after I create it, I can call its start method right away. In other words, I don't even need a variable to store the my thread object because I'm just using it right away. Okay. Are there any questions about this? Nope. Okay. So I think we are pretty much done here. So I'm gonna save.
But then there's no reference to that my thread
Object.
So
Wouldn't it get deallocated because of a garbage collection?
Yeah.
It does not, because the start method is going to quote unquote register that particular thread with the system.
Oh.
So the reference to this object is actually now in the Android framework itself, and that's why it's not going to disappear. Okay, that's a good question. I knew that somebody's going to ask that question. It's a very good question, because if I don't have a reference to it, and I'm just calling a method to it, doesn't that mean that this is going to be disappearing soon because nobody needs it anymore? But the start method actually will register this object with the Android framework, the multi-threading framework. So the Android framework, which is outside of this program, will have a reference to this object, so that I'm not worried that it will disappear. All right. So let's go ahead and try this out. And of course, there's no device already defined because I changed the path and all that stuff. So we'll Android virtual devices, device definition. I wonder if I can start.
Yeah, create AV.
Yeah, okay, I have to create it. Okay, let's create a small one. API level 19, and choose the Intel processor, because otherwise it'll take forever to start. And I have to select the scan, QVGA. There we go. Click OK.
What is QVGA again?
I think it's quarter VGA. So it's basically 1/4 of the resolution of VGA. So we'll launch it. It's starting. I can see my external hard drive blinking. Here we go. I tried this when when Android first came out, and the emulator took forever to start. This is like really, really fast by comparison. All right,
I think especially because you're using the x86 emulator, which I
right, exactly. I can use the acceleration because of that.
Yeah, I remember trying it just using the ARM.
Mm-hmm.
Yeah, I was like 30 minutes down the line, I was like still waiting.
Well, that's the nice thing of using Linux as the underlying operating system is you can retarget it pretty easily to different processors. All right, so let's go ahead and run it as an Android application. Switch back to here, and we're just waiting for the launch to happen. And this test thread has stopped. Okay, I think I forgot to initialize something. All right, so here's the question: what do I do at this point? The program just stopped execution, and I have no idea why it stopped execution. Okay, I can use a breakpoint. I can also use the debugger. Okay, or I can switch my view to the debug perspective. And once I switch to this one,
Error.
can't find API database, API check.
That's for RPS.
Sorry?
Resource RPS.
Oh, right. It's for RP. Oh, resources RPS, so that's okay. Alright, so let's go ahead and debug the program. So we debug test thread. single step through this. Has it stopped already?
It looks like it's just waiting.
No, this is my current execution point.
Yeah, it's at the breakpoint.
I did not set up any breakpoint, so it's really just stopped here.
Any new contacts?
And getting back to here, it has started. Unfortunately, test thread has stopped. In my test program, it is now disconnected. So I need to look at the logcat. So let's see, how do I get to logcat?
Midpoint. Yeah, go back to your Java, then try logcat again.
Okay. It doesn't have logcat here. It does have error log.
Well, normally it would.
Oh, there it is.
Oh yeah, it is. It's just in. Go straight up.
Okay, I have a null pointer exception. It's inside main mythread.run. So I probably forgot to initialize TV, but I thought I did. Well, TV is null. I'll bet you that's the reason.
Yeah.
TV is somehow null. It was not able to find it by ID and cast it into a text view. All right, so let's go ahead and check it. We'll go through the debugger again. Fine. Am I at the breakpoint? Yep. All right. So let's hover over this. It is no. So I was not able to find my view by ID. It returned a null.
I've been having that issue,
Yeah.
and I haven't even encountered that issue even with multiple objects.
Well, there's a way to get around it. If I cannot get a hold of a view, I can still get a hold of the
Or we can just directly plug in the like set text without using TV.
well, the set view. I mean, yeah, set text is not going to work either. Because if I get back here, it's set text is also going to refer to TV. So if TV is null, then I have a problem. So I can't really get around that problem until I can get to the object. So the question is, why is it not finding it? Okay, let's switch to.
If you bring up maybe the resource and look at the ID resource, see if it's there.
So I can look at, let's see. Under, okay, let's take a look at the XML file first, okay? It is +ID/text view 11. That should add the ID, if it's not already there. And the source.
Scroll down to values.
Nope, it's not under values. It is. There's an R file. It is under generated somewhere. Generated Java file that should contain that. I think it's under here. Yep, there we go. Okay, so we want to look for text view. This is. Sorry.
Looks like it's an alphabetical order. Just go to the bottom.
There's r.java, there's, when you open it up, there's a ID Yeah.
And here it is. It's defined. But it's not getting it when
That's
it's
weird. Oh no.
Hmm?
Okay, it's alphanumeric.
I recall running into this issue, but I'm not sure how I got around to it.
But you did.
Yeah, I recall getting to this issue.
And this issue is kind of new too, because I have been doing this from the beginning of the class, with all the buttons and whatnot. The ID is usually automatically generated to begin with, and I did not have to create it myself.
How about we just delete the text view and just recreate it? Simplest thing.
Mm-hmm. All right, so we go to fragment and go to graphical layout. Get rid of this. Draw another one and look at its properties. And this one already has an ID, created.
Yeah.
And this is text view 1, which is fine.
Why did the original one not have an ID?
The original one did not have an ID.
I know, why?
I do not know, because that's not the behavior of Eclipse when we used it earlier in the semester.
Was the problem that we're having last time also associated to the fragmented view?
Mm-hmm.
Then maybe it should not being able to find it in the fragmented view.
Hmm.
For whatever reason. Sorry, what's not working right now? What's not working? Is it not having an ID set?
Right. Yep. All right. New project visit failed.
That was 2 months ago.
That's 2 months ago. And unhandled event loop exception. It's under Eclipse's. This is Eclipse's own problem.
Yeah.
All right, we'll do the typical engineering approach.
Reboot it.
Yeah. Hey, at least I'm not kicking it first. Usually the reboot is preceded by actually booting, the device.
Step 1, reboot.
Yeah,
Step
we have
2, boot.
we have a real engineer here. This is how we usually do things to check for connections problems. We shake it, we knock it around, see if it makes any difference. Oh, it does make a difference. All right, so we'll go ahead and change this to text uppercase view 1. All right, that's fine. That's easy to fix. Save. All right, and then just run it. No pointer exception, and it is and it's not working. Okay. Well, in my test program, it did work, and the difference is I did not use a view to do the post. Instead, I used run in UI thread of the main activity itself. So we can try that. So we have.
Oh, what's the difference between the Android, the main activity, and the fragmented activity?
A fragment is basically a sub-activity. It is a part of it, instead of, because it has to do with my minimum API is no longer less than 11. So starting with Android 3.0, it supports, it breaks the screen up into 2 parts. So instead of having one activity to represent the entire screen, it has a fragment that represents a second half of the screen or the bottom half of the screen, which is where most stuff is happening. Because the action bar is its own thing. That's why we have a fragment to separate the screen into 2 different portions. Okay, so let's try this. Okay, we'll do an activity. Oh, this is activity bar. Okay. Okay, so we'll do this, and then we have to initialize it also when we do on create. And the way to initialize this one is easy because it's just this.
Yeah, as I thought, a lot of people are mentioning that find view by ID returns a null when referring to an object in a fragment.
Okay. But is there a solution to that?
Still looking.
Okay, so instead of doing a post here, I'm going to switch to a dot run on UI thread, and I still have to specify the same runnable, which is R. But if TV itself is null, then I still end up with the same problem because set text is not going to work either.
It looks like if you do a get view dot find view by ID, it may work.
Okay. So instead of just using find view by ID,
Yeah, get view prints in
it's undefined for the type main activity. Did I mistype it?
lowercase get, capital V, lowercase IEW.
Well, we are not dealing with an activity anymore. We're dealing with a action bar activity. So maybe that's the reason, because that's the only thing that we change is action bar. We're dealing with action bar activity here, and it is in the support library. So maybe that's the reason why we have an issue. But I used the same way, in my other application, and it did not run into this problem.
And you use the fragment, right?
Can I use a fragment? Exactly. Yep. So for the rest of it, it's really the same thing. You know what? That's also okay. Let's do that. Let's actually load up this one here and find out what the differences are. Okay, so save it into downloads, and we'll unzip it into downloads and then import it into Eclipse. Nope, doesn't want to do it. By hand. Alright, so getting back to Eclipse, we'll do a import. Let's see. Import. And it's going to be an Android project. Android code directory is going to be under downloads, test threads. So test threads is the new one. Okay, I see how it's different because in this one I use find view by ID first, and then from there use set text. So I'm not using find view by ID outside and do the initialization. Remember that. All right.
So like a made up find view by ID.
Well,
It's me. Main
sorry?
activity.
That's the difference.
Yeah, me is a main activity, so it's the same class as what we are defining here. All right, so let's go back to my program today and do the same thing. So instead of keeping track of text view constantly, we only keep track of who I am. So every time I need to use set text, I will just say a dot, which is the activity, find view by ID, and then at this point I do refer to the text view ID. So that should take care of that. Oh, I have to cast it to a text view first. So text view. And that finishes the cast. A dot find view by ID, that should return a. I'm missing one parenthesis. Go. Save. And because there's no TV here. Alright, so let's go ahead and run it. Okay. This one works. We have a counter now that is updating. Sorry? Say again? It's working now.
He's excited.
Yeah, it looks nice.
Yeah, it's very impressive. Yes, I can now count every second. But it is using a background thread. It's using a background thread with its own weight and is interacting with something that is happening on the screen. So the next question is, getting back to the preemption issue, is whether Android is preemptive or not. If a particular thread is not doing any sleep, is not doing any yield, is not voluntarily giving up any control, will the program still function correctly? That is the question. Okay, so let's go ahead and test that theory, because now that we have this program at least running up to this point, we can test it, right? Okay, so the question is, how do we test that one? Okay, so we'll go ahead and extend another thread. We'll create another subclass of a thread. So this is a private class, and I'll call this, hog thread, because that's what it's going to do. It's going to hog all the processing time.
Oh, yeah.
Okay. Hey, I wanted to automatically create my. Oh, okay, I guess not. Override public void run, and it's going to be while true, do nothing. This is a tight loop, as tight as you can get, right? So this is a loop that doesn't do anything, and
Do this.
inside.
Is it true? Do
Huh?
it again. Is it true? Do it again.
Yep. New hog thread dot start. In fact, what I'll do is I'll reverse the order. I'll create the hog first and let it start first. Okay? So if it is not preemptive, I know for sure that we should not see the number updating, right? All right, so we'll go ahead and give this one a try and figure out what it is going to do. And it's still working. Now, obviously, the battery life of this Android device is going to, be down to like a few minutes, and it'll get pretty hot.
Check your current CPU usage.
Huh?
Check your current CPU usage.
How do I do that?
Just go to
Menu.
just go to the terminal and do PS.
Oh, you mean with the
Yeah, because you're
machine?
emulating
Oh,
it.
okay.
That mean it'd be utilizing.
Yep. I can do better. I can do top. Yep, 100%. 101%.
That's crazy.
It's not crazy because it can exceed 100% because it is 100% of one core. So that means the emulator is actually using a little bit more than 100% of one single core, which makes sense. It's a really busy loop, but it is preemptive. So that will answer your question of whether it's preemptive or not. It is preemptive, which also means you can have interesting games running, because now you can have your game to run completely in the background to do all the updates, and whenever it needs to do something on the screen, that's when it needs to do a post or a run in UI thread to let the user interface thread and say, hey, I need you to do something to update the screen. That's basically all it needs to do.
How does it use more than 100% of a core?
It's using 100% of one core and a fraction of a percent of another core. So that's why you can see the percent CPU exceeding 100%. This can only happen with a multi-threading type of process, because if you have a single thread process, it can only utilize up to 100% of one core. But when you have a multi-threading process, then you have at least 2 threads running at the same time. So if one thread is using 100% of the time and the other thread is just a helper thread, then that one can take a fractional of a percent.
So if you have like a 4-core multi-threaded and it's utilizing all of them, it'll be like 400%?
Yes. It'll be 800% because with hyper-threading, the Linux kernel actually sees 8 cores, so it can spin up 8 threads all at the same time.
Assuming that hyper-threading is enabled for that.
Exactly. Yep.
For Intel, it has the turbo boost. I was wondering, is there a way to know when it actually activates in Linux?
That is a good question. Turbo boost is a hardware feature. It depends on the thermal load at the time. It depends on a lot of various factors. So it would basically dynamically bump up the internal clock speed to give you that one little extra burst of processing resources. So I'm not 100% sure whether it can be reflected here, because it may be a completely hardware thing, and software can only control whether you enable turbo boost or not. So whether it happens is completely determined by hardware. So if you have a bigger heatsink, it may happen more frequently.
Yeah, with my motherboard I can change all the criteria for that. So
for turbo boost?
Yeah, I can overclock it and have it just run to a certain point. Unless it's up to a certain load, then it'll exceed that to whatever point I specify.
Okay, so you can specify the threshold of when it is too hot to to do the boost anymore.
Yeah, and how many cores that the percentage of each core.
Okay.
Because normally it just it increases one core while other ones still are held back a little bit.
Mm-hmm. Now let me try this one thing, because if this emulator is QEMU based, then it's going to respond to Control Alt 1 and Control Alt 2 to switch between the what you're seeing here, which is the emulated screen, and also what we call a console for QEMU. So let me see, Control Alt 2. Nope, doesn't do that. Okay, so they probably locked down the feature, so I can't really do it that way.
Move it away from this, click off the screen, then try it again.
Okay.
How does it compare to one thread? I mean, the CPU usage? Do we remove the thread that we just added and run the CPU resource again? What I mean is, right now the CPU resource is taken at 101%.
Right.
With 2 threads. Let's try it with the 1 thread, the initial setup that we have.
Oh, okay, sure.
The base load.
Yeah. So if I take out hog.
Yeah.
Just comment out.
Yep. Appropriately named. And rerun the whole thing, launching, and then look at system load again. You can see it's definitely all the way down to nothing basically. Yeah, FFmpeg is the encoding program for screen recording, and that one is taking like 30% of a core. And you can see that the emulator is now taking what, 5%, 5.7%, 5.3%. So it definitely made a difference.
Yeah.
So why isn't it utilizing all the cores at maximum capacity, since it's never figuring out?
Because
it's always true, it should be utilizing.
Okay, there are several factors. The first factor is how many cores are we allocating to the virtual machine. Okay, because you can control how many actual core of your physical box you're actually allocating to the emulator. The default, I'm not 100% sure whether there's actually a control, whether I can set it, I'm not 100% sure, maybe. But you can allocate, by default, it only uses one single core. So no matter how busy or how loaded your emulated computer is, it's still only going to take up to 100% of one single core of the bare metal of the box. In other words, I can start up like 6 hog processes, and it will still only be 100% as far as the emulator is concerned if it is only allocated one single core from the host perspective. Yep.
Under certain circumstances, you may want to specify what thread goes to what core. Can you do something like that?
No, I have not done anything like that.
No, would it be possible to do something like that?
I don't think so. I think that part is, I think, okay, it's definitely done by software. Okay, so I think the software has control over, which thread is done by which core. Now, whether you have a programmatic control over that using a stock kernel, that part I do not know. I think by default the way it works is the kernel automatically do thermal loading. So if you have only one really busy thread, it is not only using one core all the time. It goes around all the different cores. This is what I observed.
Yeah.
It would do automatic thermal loading so that the heat of your processor will be spread kind of more evenly on all the different parts, so it doesn't overheat only one part.
I'm just thinking like
I think
certain specialty programs may utilize the processor cores in such a way that have automatic association would not be the best for its purpose.
Yeah, that I don't know. I do not know about that. But okay, looking at the virtual device setup screen, there's no allocation of cores here, so I cannot directly control how many cores to allocate to the virtual machine, which is okay. All right. So I think I'm finishing today's lecture here. So the only thing that I need to figure out is why is it okay to do it this way? In other words, inside run, I can this is obviously not returning null. Otherwise, I would end up with the same problem. But inside on create, if I do the same thing, try to do a find view by ID, it's returning null. So that's the question. This is an on create of a fragment, and I think that might be the issue. Is if I'm using the on create inside a fragment, the ID resource itself is not fully loaded yet. That would be my guess. But not the resource ID. It is the view object is not created yet. So that's why find view by ID return a null, because it is by this time it is not done yet.
But I would have thought that when you call an onCreate, that would be after the screen has initialized, the object on the screen has initialized.
Yeah, you would think so, but that doesn't seem to be the case, unfortunately.
But before you're actually doing anything.
Yeah. Because this one is an action bar activity, which should include both the activity and also the fragment that is containing the view. But I have a kind of sinking feeling that on create is the reason why it didn't work is because the view is not created yet.
Yeah.
So that's why find view by ID return a null, because it's not there yet. So the question is by what time is it constructed, and I can reliably use find view by ID to locate it, because the call itself is fine. I mean it's obvious that this call is successful.
Can you breakpoint? No, that'll be XML.
No, you can breakpoint.
I was just thinking breakpoint in the call for the fragment to be created.
Before the fragment is created.
Yeah, on the call for the fragment to be created, and see where at what point does it do that, before or after your code.
I can do that, but I want to look up action bar activity as a class first.
Good.
And figure out, from that, whether it has anything that's different. It is a subclass of activity, and that's how it inherited on create. But the problem is, when I'm doing this on create panel menu, on create, does it have any special hook for me to attach to that makes sure that everything is created at a time? That's the question. On create panel view initiates the view to display in the panel for feature ID. No, that's not related to what we want to do. So I will take a look at this.
Invalidate would only refresh the information, not finalize any creation of objects. So invalidate would only update information associated with objects, not code for creating the object.
Invalidate, basically sends a message to the view and
Yeah.
basically say, okay, paint yourself. That's what triggers on call.
Yeah, I'm just thinking, would invalidate also allow it to go to the UI and finish what's done there before it returns, and then you can call a find view ID.
Oh, I see. Well,
It
invalidate
just hasn't had a chance to do that yet.
Mm-hmm.
And I'm just wondering if those two can be associated.
I don't know. Well, I don't think so, because what invalidate does is it only sends a message. It doesn't trigger the operation right away. It only sends a message back to the message queue.
Mhm.
So eventually, the message loop, the looper, is going to get to that message and say, "Oh, okay, this invalidate goes to that particular view. You need to redraw yourself now."
Yeah.
So
I'm just thinking, would that since you're calling it then it would be the
But invalidate applies to a view, so you still need find view by ID to locate the right thing first. Chicken and egg. Okay, so let's take a look at onCreate. Perform initialization of all fragments and loaders. So it should include the fragments, and that particular text view is inside the fragment, so I would assume that it has to be done at a time. Parameter bundle. If activity is being reinitialized after previously being shut down, then this bundle contains the data it most recently supplied in on-save instance state. I'll have to look into this, because we did not have this problem before, but after we switched the minimum API to level 11 instead of the previous 8 or so, then we started to have this issue. Okay, I think I can stop the recorder now.